Good day everyone! It is my pleasure to have this simple presentation as we embark on this exciting journey into the world of physics. Physics, often referred to as the fundamental science that holds the key to understanding the very fabric of our universe. Today, we're going to dive into four different intriguing concepts of physics, which includes the measurements, motion in 1D, Newton's law, and lastly, the motion in 2D. Now, if you're ready to learn, buckle up and let's get into it. First, measurements. It is associated with finding the measurements of the unknown using different measuring units, and it includes the conversion of unit. But first, what is a conversion factor? A conversion factor is a factor used to convert one unit of measurement into another. A simple conversion factor can convert meters into centimeters, or a more complex one can convert miles per hour into meters per second. Now, I prepare one problem regarding the conversion of units. For the sample problem regarding measurements, the adult weighing 150 to 180 pounds have an average of 1.3 gallons of volume of his blood in the body. What is this volume in milliliters? For this problem, first thing that we need to do is to list down all possible conversion factor for each unit of measurement. 1 gallon is equal to 3.79 liters and 1 liters is equal to 1000 ml. For the solution, we're going to use dimensional analysis. 1.3 gallons times 3.79 liter over 1 gallon times 1000 ml over 1 liter. Cancel all similar units and then it will result to 4927 ml. Let's proceed to the next topic. Our second topic, motion in 1D. There are a variety of quantities associated with the motion of objects: displacement and distance, velocity and speed, acceleration and time. Knowledge of each of these quantities provides descriptive information about an object's motion. This will lead to the study of kinematics. But what is kinematics? Kinematics is the study of a motion of mechanical points, bodies, and systems without consideration of their associated physical properties and the forces acting on them. The kinematic equations are a set of four equations that can be utilized to predict unknown information about an object's motion if other information is known. The four kinematic equations that describe an object's motion are shown in this picture. Let's proceed to the sample problem. For this sample problem in motion in 1D kinematics, John is waiting on a pedestrian lane. When the marshal finally allowed to cross over, John accelerated from the rest at a rate of 2.0 meter per second squared for a time of 4.30 seconds. Determine the displacement of John during the time period. First thing to do is to list down all the given values. Initial velocity of 0 meter per second, the time is 4.30 seconds, and acceleration is 2.0 meter per second squared, and the displacement is missing. We can solve this problem through the use of one of kinematic equation or formula. The formula is displacement is equals to initial velocity multiplied by time plus 1/2 multiplied by acceleration multiplied by the square of time. Then substitute the given values and the result is 0 meters plus 18.49 meters. Then the final answer for displacement is 18.49 meters. The free body diagram is also included and must be included to illustrate the given process of the problem. Let's proceed to the third topic, which is the Newton's law of motion. Isaac Newton, a 17th century scientist, put forth a variety of laws that explain why objects move or don't move as they do. These three laws have become known as Newton's three laws of motion. Newton's first law of motion is often stated as an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force, sometimes referred to as the law of inertia. whereas the second law states that the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force in the same direction as the net force and inversely proportional to the mass of the object. Lastly, the third law states that for every action, there's an equal and opposite reaction. Let's proceed to the sample problem. For the sample problem regarding the first law of motion, Frank spends most of his Sunday afternoons at rest on the bed, watching series of movies and consuming large amount of food. What effect, if any, does this practice have upon his inertia? Explain. Therefore, the answer is Frank's inertia will increase. Frank will increase his mass if he makes a habit of this, and if his mass increases, then his inertia increases. Just like in the first law of motion, it states that the more mass, the more inertia it is, and the less mass, the less inertia it will have. For the sample problem in the second law of motion, determine the acceleration that results when a 20 Newton net force is applied to a 4 kg object and then to a 10 kg object. Write the given values, which is Newton or net force is equals to 20 Newton, mass is equals to 4 kg or 10 kg. To solve this problem using the formula for the second law of motion, net force is equals to mass multiplied by acceleration, and the derived formula for acceleration is A is equals to net force over mass. Then substitute the given values for each solution. This problem has two solutions for different masses. Then for the final result, the acceleration for the 4 kg object is 5 meter per second squared, and for the 10 kg object, it is 2 meter per second squared. For the action-reaction forces of this illustration, when you push the wall, it serves as the action force. Then the wall pushes back, it is the reaction force acting on it. Let's proceed to the next topic. For our last topic, it is all about motion in 2D. In two-dimensional projectile motion, such as that football and other thrown object, there is a both vertical and horizontal component of the motion. Here are one of the sample problem in motion in 2 dimension. For the sample problem in motion in 2D, to be specific in a horizontally launched projectile, a ball is kicked horizontally off a 42.0 high hill and lands a distance of 55.0 meters from the edge of the hill. Determine the initial horizontal velocity of the soccer ball. To solve this, get the horizontal and vertical information. For the horizontal information, x is equals to 55.0 meters, and the VIX or the initial velocity is missing. Acceleration is 0 meter per second squared, and for the vertical information, y is equals to 42.0 meters, and the initial velocity is equals to 0 meter per second, and the acceleration is the gravity, which is the negative 9.8 meter per second squared. For the solution in finding the time, we're going to use the formula of y is equals to initial vertical velocity multiplied by time plus 1/2 multiplied by vertical acceleration multiplied by square of time. Then substitute the given values. Negative 42.0 meter is equals to negative 4.9 meter per second squared times t squared. To cancel it, divide by negative 4.9 meter per second squared by both sides, and then the result will need to square to remove the square root of time. Then the final time will result to 2.928 seconds. To solve for the horizontal initial velocity, use the formula of x is equals to initial velocity times the time. Substitute the values, then we will obtain the answer for the initial velocity, which is 18.78 meter per second. And that's how we end our discussion. Remember that knowledge knows no bounds, so let's keep pushing the boundaries of our understanding and continue to be inspired by the wonders of physics. Thank you for joining me on this journey, and may your pursuit of knowledge be as infinite as the physics knowledge itself.